On November 15, 1943, 4 days before the first shells would rain down on Betio Island, Rear Admiral Keiji Shibasaki stood inside his command bunker surrounded by walls of reinforced concrete 5 feet thick and proclaimed to his garrison of 4,500 elite Special Naval Landing Force troops, a guarantee that echoed through the fortified tunnels. 1,000,000 men cannot take Tarawa in 100 years. The 53-year-old veteran of China campaigns surveyed his engineering masterpiece with justified confidence. Nearly 500 pillboxes studded the 2-mile-long island, each one a concrete fortress with walls thick enough to withstand direct artillery hits. 8-inch naval guns salvaged from warships pointed seaward from steel and concrete emplacements. Machine gun positions covered every yard of beach with interlocking fields of fire. Barbed wire entanglements stretched across the coral reef that surrounded Betio like a natural moat. Anti-tank ditches zigzagged inland. Shibasaki had transformed this flat coral atoll into what Japanese engineers called the most heavily fortified square mile in the Pacific theater. What the admiral could not see from his underground fortress was the gathering storm of American naval power, assembling 200 miles to the east. This is the story of how the most devastating concentration of naval artillery fire in Pacific War history to that date transformed Shibasaki's impregnable fortress into rubble and shattered Japanese confidence in concrete defenses, revealing a dimension of American firepower that imperial planners had catastrophically underestimated and forcing a complete reassessment of island defense doctrine that would echo through every subsequent Pacific battle. The strategic importance of Betio Island within Tarawa Atoll made Admiral Shibasaki's confidence understandable through the lens of Japanese defensive thinking in late 1943. Located in the Gilbert Islands chain, Tarawa sat astride American supply lines driving toward the Marshall Islands and eventually the Marianas, stepping stones toward the Japanese home islands themselves. Imperial General Headquarters had designated the Gilberts as the outer perimeter of absolute defense, positions to be held at all costs to delay American advance and inflict casualties severe enough to erode Washington's will to continue the Pacific offensive. Shibasaki commanded the Sasebo 7th Special Naval Landing Force and the 111th Pioneers, elite troops equivalent to Marines, not the second-rate garrison infantry defending many outer islands. These men had trained specifically for defensive warfare, and many were veterans of brutal fighting in China. Tokyo had given Shibasaki 8 months and unlimited resources to fortify Betio. The result was a defensive system that represented the pinnacle of Japanese military engineering philosophy. Use concrete and steel to create an impenetrable crust. Force attackers into killing zones where firepower advantage disappears. Inflict unacceptable casualties during the vulnerable amphibious assault phase. Japanese doctrine calculated that heavily fortified island strongpoints would force Americans into costly frontal assaults, buying time for the combined fleet to sortie and destroy invasion forces at sea during the vulnerable resupply phase. Every previous amphibious assault in the Pacific had demonstrated the terrible difficulty of attacking fortified positions from the sea. Tarawa was designed to be the island where American offensive momentum died. The physical fortifications Shibasaki constructed on Betio demonstrated sophistication that American intelligence officers would later compare to the Maginot Line compressed into 2 square miles. The nearly 500 pillboxes varied in design but shared common features: walls of reinforced concrete between 4 and 5 feet thick, roofs layered with steel rails and coconut logs covered with sand to absorb blast effects, firing ports just 3 to 5 inches wide providing maximum protection, while allowing machine gun traverse. Larger bunkers housed the 8-inch coastal defense guns, with walls up to 7 feet thick. The Japanese had imported cement from as far away as the home islands. Korean laborers worked alongside military engineers pouring concrete day and night. The fortifications interconnected through communication trenches deep enough to allow movement, while protected from direct fire. Ammunition bunkers built into rear walls of gun positions held 12 rounds per emplacement in blast-proof concrete compartments. Machine gun positions were specifically sited to provide overlapping fields of fire across the beaches, with no dead ground. The defensive plan assumed that even if some positions fell, The network would maintain coherence through mutual support. Tank obstacles consisting of concrete pyramids and steel rails driven into coral fronted the seawall. The seawall itself, built of coconut logs and coral, rose 4 feet above high tide and presented a barrier to vehicles. Most ominously, the coral reef extended 500 to 1,000 yards offshore depending on the tide. Shibasaki had calculated that American landing craft would ground on the reef at low tide, forcing Marines to wade hundreds of yards under fire with no cover. Every element worked together to create what Japanese planners called a defense in depth despite shallow depth, using engineering to multiply the effectiveness of each defender. Admiral Shibasaki's confidence also drew from intelligence assessments, suggesting American forces lacked the patience or doctrine for prolonged siege warfare against hardened fortifications. Japanese intelligence officers studying previous Pacific landings noted that American pre-invasion bombardments were typically measured in hours, not days. At Guadalcanal and the Solomons, Marines had faced primarily field fortifications, log bunkers, and light-prepared positions, not the steel-reinforced concrete now covering Betio. Shibasaki and his staff calculated that even if bombardment destroyed surface structures, the deep bunkers and underground command posts would remain intact, allowing defenders to emerge and man weapons once the bombardment lifted. The tactical assumption was straightforward. Concrete 5 feet thick cannot be penetrated by naval gunfire except through impossible direct hits, and even then, perhaps not at all. Japanese defensive manuals from 1943 specified concrete thickness standards based on calculations of shell trajectories and explosive effects. Engineers believed that shells striking at the typical flat angles of naval gunfire would ricochet or detonate on surface layers without penetrating to interior spaces. The coconut log and sand covering would absorb blast effects. Underground shelters connected to firing positions by covered trenches would protect personnel during bombardment. Once naval fire shifted inland, defenders would race to positions and catch assault waves in the water, where they were most vulnerable. This doctrine had worked at other fortified islands. Shibasaki had every reason to believe it would work at Tarawa. What Shibasaki did not know, sealed inside his bunker complex with communications limited to radio and runner, was that the Imperial Navy's intelligence network had failed catastrophically to assess the true scale and sophistication of American naval gunfire doctrine evolving in the Pacific Fleet. While Japanese planners studied previous bombardments lasting hours, American fire support doctrine was undergoing rapid transformation based on hard lessons from Guadalcanal and subsequent operations. By November 1943, the Fifth Fleet under Vice Admiral Raymond Spruance had developed detailed fire support plans coordinating battleship, cruiser, and destroyer fires with carrier aviation in a systematic approach to destroying fortified positions. The fire plan for Tarawa represented a quantum leap in both volume and precision compared to earlier operations. 3 battleships of Task Force 53 would deliver the main weight of fire: USS Colorado, BB-45, USS Maryland, BB-46, and USS Tennessee, BB-43, all carrying 8 16-inch guns apiece. Supporting them were 4 heavy cruisers with 8-inch batteries and 3 light cruisers with 6-inch guns. 9 destroyers added their 5-inch dual-purpose guns to the bombardment plan. Carrier aircraft from Task Force 50 would coordinate with naval gunfire, shifting between bombing and strafing runs. The total throw weight represented approximately 4,000 tons of high-explosive and armor-piercing shells, delivered with increasing precision as gunnery officers refined techniques. This was not the hasty bombardment of earlier operations. This was systematic destruction planned by officers who understood they were testing doctrine that would determine how America conquered fortified islands all the way to Japan. The physical characteristics of the 16-inch Mark V and Mark VI guns mounted on Colorado-class battleships represented firepower that Japanese intelligence had theoretically catalogued but never truly appreciated in application against land fortifications. Each armor-piercing shell weighed 2,700 pounds and left the barrel at 2,300 feet per second. The high-explosive shells, designed for use against softer targets, weighed slightly less but carried between 200 and 250 pounds of TNT explosive filler compared to the 100 to 150 pounds in armor-piercing rounds. These shells were designed to penetrate the heaviest battleship armor afloat. At 20,000 yards, a 16-inch armor-piercing shell could punch through 12 inches of hardened steel plate, angled to maximize deflection. Concrete, even 5 feet of reinforced concrete, presented a fundamentally different material challenge. Where armor plate deflected through hardness and angle, concrete failed through shattering and spalling. The massive kinetic energy of a 2,700-pound projectile traveling at supersonic velocity did not dissipate on impact with concrete. It transferred into the target matrix, creating compression waves that shattered the material from within, even if the shell did not fully penetrate. Armor-piercing shells with delayed fuses could penetrate several feet before detonating, turning bunker interiors into killing zones of blast overpressure and concrete fragments. High explosive shells detonating on the surface created craters several feet deep and sent shock waves through connected structures. The 8 16-inch guns on each battleship could fire approximately 2 rounds per minute per gun in sustained fire, meaning each battleship delivered 16 2,700-pound shells per minute when all guns engaged. Over the course of multi-hour bombardment, the cumulative destructive effect exceeded anything Japanese engineers had modeled when calculating fortification requirements. The bombardment plan developed by Rear Admiral Howard Kingman, commanding the Fire Support Group, and Rear Admiral Harry Hill, commanding Task Force 53, represented methodical American operational planning at its most thorough. Intelligence officers had studied aerial reconnaissance photographs for weeks, identifying and cataloging every visible fortification. Each concrete structure received a designation and priority ranking. The largest coastal defense guns constituted Priority 1 targets for immediate counter-battery fire. Priority 2 included pillboxes covering the landing beaches. Priority 3 encompassed inland fortifications and supply dumps. The plan allocated specific ships to specific sectors and specific targets within those sectors. Spotting officers would observe shell falls and adjust fire using a systematic grid system marked on detailed maps. Carrier aircraft would mark targets with smoke bombs and strafe positions to suppress return fire against spotting aircraft. The bombardment would begin before dawn on D-Day, November 20th, 1943, and continue for 3 hours before the first assault wave hit the beaches. Cruisers and destroyers would then shift to close support, engaging targets as Marines identified them during the assault. The scale was unprecedented. Estimates indicated the Fire Support Group would expend approximately 1,200 to 2,300 rounds of 16-inch shells alone, not counting the thousands of 8-inch, 6-inch, and 5-inch rounds from cruisers and destroyers. Japanese defenders on Betio had never experienced anything approaching this volume of precisely directed heavy naval gunfire. Neither had any other defending force in the Pacific War to that date. At 05:07 hours on November 20th, 1943, the 16-inch main battery of USS Maryland erupted in flame as the first salvo of the Tarawa bombardment screamed toward Betio Island 6 miles distant. The 4 shells, each weighing more than a small automobile, covered the distance in less than 30 seconds before impacting near the southern shore, where Japanese coastal defense guns had been identified. The flash of detonation lit the pre-dawn darkness like miniature suns. Within seconds, Colorado and Tennessee joined the bombardment, their own 16-inch guns adding to the thunder rolling across the lagoon. The noise was beyond description. Marines aboard transport ships preparing to load into landing craft felt the concussion through steel hulls. The muzzle blast from a 16-inch gun created overpressure that could injure personnel standing too close. When all 3 battleships fired in salvo, the sound merged into continuous rolling thunder. Smoke and flame engulfed the gun turrets. The battleships themselves recoiled visibly in the water from the recoil forces. This was just the opening movement of a 3-hour symphony of destruction. For the Japanese defenders inside their bunkers on Betio, the world had suddenly transformed into hell. The first shells to find their marks struck with devastating effect. One 16-inch armor-piercing round penetrated a coastal gun emplacement and detonated inside the ammunition magazine. The resulting secondary explosion created a fireball that shot hundreds of feet into the air and obliterated the entire position, killing the gun crew instantly. Spotting officers aboard the battleships observed the hit and shifted fire to the next priority target. The systematic destruction of Shibasaki's fortress had begun. Inside the Japanese command bunker, Admiral Shibasaki experienced the bombardment through the medium of earth and concrete transmitting shock waves from distant impacts. Each heavy shell impact sent tremors through the ground, dust filtered from the ceiling, the radio filled with fragmented reports from outlying positions describing impacts, fires, casualties. What Shibasaki could not know yet was the true effectiveness of the bombardment against his concrete fortifications. Japanese doctrine had assumed individual positions might be destroyed by lucky hits, but the overall defensive network would maintain integrity. The American fire plan was proving that assumption catastrophically wrong. The sheer volume of fire being delivered meant that bunkers did not have to be destroyed by single lucky hits. They could be systematically engaged with multiple shells until they failed. Spotting officers called corrections after each salvo. If the first salvo landed short, the second would land long. The third would bracket the target. The fourth would strike home. Once a position was engaged, fire continued until observers confirmed destruction or suppression. The coastal defense guns constituted the first priority because they threatened the battleships themselves. These positions, despite their thick concrete protection, were being systematically eliminated through precise counter-battery fire. By 05:45 hours, 3 of the 4 large coastal guns had been silenced. The fourth would survive the bombardment, but its crew would be too stunned and disorganized to engage effectively during the assault. The elimination of the coastal batteries removed the primary threat to American ships and allowed the bombarding vessels to close range and increase accuracy against smaller targets. As dawn broke and visibility improved, the cruisers and destroyers joined the bombardment with their smaller but more numerous guns. USS Portland and USS Indianapolis, heavy cruisers mounting 8-inch batteries, engaged pillboxes along the northern beaches where the main assault would land. Light cruisers with rapid-fire 6-inch guns walked salvos across the beach defenses. Destroyers closed to within 3,000 yards, near point-blank range for naval gunnery, and engaged specific pillboxes with direct fire. The intensity of fire reached levels that made systematic observation difficult. Betio Island disappeared beneath smoke and dust. Coconut palms, once providing camouflage for fortifications, were shredded into splinters or set ablaze by high-explosive shells. The volume of fire exceeded even the optimistic projections of the fire plan. Gun crews worked in mechanical rhythm, loading and firing until barrels glowed hot and paint burned off the guns from heat. Magazines that had been stocked with hundreds of shells emptied, as shells were run up to the turrets in continuous streams. By 0800 hours, some gun positions had expended so much ammunition that logistics officers worried about supply for the afternoon and following days. The bombardment continued without slackening. At 0900 hours, carrier aircraft arrived overhead and began dive-bombing runs on targets marked by naval gunfire spotters. The coordination between aerial bombing and naval gunfire had been carefully planned. As aircraft rolled into dives, gunfire lifted to avoid hitting friendly planes. After bomb runs, naval fire resumed. The integration of multiple fire support systems represented a maturity of amphibious doctrine that the Japanese had not anticipated. The effect of high explosive shells on the coconut log and sand coverings that protected concrete bunkers demonstrated a vulnerability Japanese engineers had not adequately considered. While the logs and sand absorbed some blast effect from shells detonating on the surface, sustained bombardment literally excavated the protective layers. Initial hits scattered sand and splintered logs. Follow-up rounds now struck increasingly exposed concrete. The concrete itself, while thick, was not homogeneous in quality. Some bunkers had been constructed with high-grade cement and steel reinforcement. Others, built later as resources became scarce, used lower grades of concrete with less reinforcement. High explosive shells detonating against even 5-foot-thick walls created crater zones several feet deep. Repeated hits on the same structure could erode walls until they failed. Armor-piercing shells with delayed fuses penetrated 2 or 3 feet before detonating, creating interior blast effects that killed occupants even if the structure remained standing. The Americans were also using a tactic that Japanese planners had not encountered before: systematic re-engagement of the same target with different shell types. An initial high-explosive shell would strip away protective covering. A follow-up armor-piercing shell would penetrate and destroy the bunker interior. A final high-explosive shell would collapse the damaged structure. This methodical destruction of individual fortifications was being applied systematically across hundreds of positions. The American fire support doctrine was revealing itself as fundamentally different from the hasty bombardments the Japanese had studied. This was not suppressive fire intended to keep defenders' heads down. This was annihilation fire intended to physically destroy fortifications before the assault began. By 0930 hours, after more than 4 hours of continuous bombardment, Admiral Hill aboard USS Maryland made the decision to commence the assault despite the original H-hour of 1000 not yet arriving. Spotting officers reported that much of the visible defensive structure on Betio had been destroyed or suppressed. Smoke covered the island so thickly that continued precision fire was becoming difficult. The assault waves had been circling in their landing craft for over an hour, Marines suffering from seasickness and anxiety. Hill ordered the first wave to proceed toward the beach, while bombardment shifted to inland targets. This was the critical moment of amphibious assault, the transition from fire preparation to ground assault. Japanese doctrine assumed this moment of vulnerability would allow surviving defenders to man positions and slaughter assault troops in the water. At Tarawa, that assumption would prove only partially correct. The bombardment had been so intense and sustained that many defenders were dead, wounded, or too stunned to immediately respond. The ones who did emerge from bunkers to man positions found themselves in a landscape utterly transformed. Where the morning had revealed a fortified island with carefully prepared fields of fire, there now existed a moonscape of craters, burning debris, and shattered concrete. The carefully maintained firing lanes were blocked by rubble. Communication trenches had collapsed. Many pillboxes that appeared intact from outside proved to have interiors filled with dead and wounded defenders, killed by blast overpressure when shells penetrated or detonated against walls. The defensive network that Shibasaki had confidently declared impregnable was functioning at perhaps 40% effectiveness, with many key positions eliminated entirely and others degraded to the point of near uselessness. The tide, however, intervened in a way that no amount of firepower could overcome. Intelligence officers had miscalculated the depth of water over the reef. At low tide, most landing craft grounded 500 to 700 yards from shore. Marines of the 2nd Marine Division clambered over the sides and began wading through chest-deep water toward the beaches, while Japanese defenders who had survived the bombardment opened fire from positions still intact. This was the moment Admiral Shibasaki's defensive plan had anticipated. Despite the devastating bombardment, enough machine gun positions remained operational to inflict terrible casualties on Marines struggling through the water. The wading advance took between 15 and 20 minutes for each man, an eternity under fire. Marines weighed down with equipment struggled through coral holes and shell craters in the reef. Machine gun fire from surviving pillboxes stitched across the water. Mortar rounds dropped among the wading formations. The casualties mounted rapidly. Companies that hit the beach had suffered 20, 30, even 50% losses during the approach. The ones who reached the seawall found themselves pinned down by fire from positions the bombardment had missed, or only partially damaged. Despite the most intensive pre-invasion bombardment in the Pacific War to date, the assault on Tarawa was proving to be exactly the costly, grinding battle that Japanese defensive doctrine had intended. The question now facing the Marines was whether the partial destruction inflicted by naval gunfire would be enough to allow them to establish a foothold and bring the battle ashore. For Admiral Shibasaki, watching reports come into his command bunker, the battle was following the script he had planned. The bombardment had been devastating, yes, worse than anticipated, but the defenses were holding. The Americans were dying in the water. Perhaps his confident prediction would prove accurate after all. What neither Shibasaki nor the Marines struggling ashore yet understood was that the battle for Tarawa would ultimately vindicate American firepower doctrine, while simultaneously exposing its limitations. The naval bombardment had accomplished something unprecedented. It had destroyed or neutralized a significant percentage of hardened concrete fortifications through sustained, precisely directed fire. The 16-inch shells had penetrated defenses that Japanese engineers had calculated as impenetrable. The problem was not firepower inadequacy, but rather the inherent limitation of naval gunfire against targets as small and numerous as individual pillboxes on a 2-mile-long island. Even with 4,000 tons of shells expended, some positions would inevitably survive. Some bunkers were simply too well constructed or positioned in dead ground where naval gunfire could not reach. Others had walls thick enough and roofs layered enough to survive even direct hits from 16-inch shells. The beach defenses nearest the waterline were partially protected by the seawall itself, which created a shadow zone from flat trajectory naval gunfire. The bombardment had transformed the battle from impossible to brutally difficult, but had not eliminated the Japanese capacity to resist. Marines would spend 3 days and nights clearing the island in close combat, using flamethrowers, satchel charges, and point-blank tank fire to destroy bunkers the naval guns had failed to eliminate. The 76-hour battle would cost 1,000 Marines killed in action and 2,000 wounded. Of the 4,500 Japanese defenders, only 17 would survive to be captured. Shibasaki himself would die, probably during the second day, when Marines overran the command bunker. The revelation of American firepower superiority during the Tarawa bombardment was documented not just through physical destruction visible in post-battle damage assessment, but through the testimony of the few Japanese survivors whose accounts were preserved in intelligence reports. One of the 17 prisoners taken alive, a naval rating named Tadao Onuki, who had served in a coastal defense position, provided interrogators with a detailed account of experiencing the bombardment from inside a bunker complex. His testimony, recorded in 5th Fleet intelligence summaries, described the transformation from confidence to terror as the shelling continued hour after hour. "We believed the bunker would protect us," Onuki stated through interpreters. "The concrete was very thick. We were told shells could not penetrate. At first, when shells hit nearby, the sound was very loud, but we felt safe. Then a shell hit directly on our bunker. The sound was beyond anything I can describe. The entire structure shook. Dust fell like rain. We could not hear each other even when shouting. Then another shell hit, and part of the wall fell inward. We understood then that the concrete was breaking. We could not believe it. Another shell came through the roof. The explosion killed everyone except 3 of us who were in the corner. I could not hear for hours afterward. Everything was ringing." This testimony, repeated in variations by other survivors, documented that Japanese confidence in concrete fortifications had been based on theoretical calculations that failed to account for the sustained application of extremely heavy caliber shells with precision fire control. The bunkers were strong. The shells were simply stronger. The psychological impact of the naval bombardment on Japanese defenders who survived it proved nearly as important as the physical destruction. Multiple survivor accounts described men emerging from bunkers in states of shock, unable to fight effectively even though physically unwounded. The sustained nature of the bombardment, lasting hours rather than the minutes or tens of minutes that Japanese training had prepared them for, created cumulative psychological effects that degraded combat effectiveness. One prisoner, a sergeant in the Special Naval Landing Force named Kiyoshi Ota, told interrogators, "We trained for bombardment by running drills with explosions. Maybe 10 minutes, maybe 20. At Tarawa, the shelling never stopped. 1 hour, 2 hours, 3 hours. We could not tell time. The whole world was shaking. We thought it would never end. When it finally stopped and we came out, the island looked like a different place. We did not know where we were. All the landmarks were gone. Many men could not think clearly. They just sat. Officers were shouting orders, but some men did not respond. I think their spirits were broken." This testimony illuminated a dimension of firepower effectiveness that went beyond physical destruction, the ability of sustained bombardment to break unit cohesion and individual will to resist. Japanese defensive doctrine had accounted for casualties from bombardment, but had not adequately considered the degradation of survivors' combat effectiveness. Men who were physically capable of fighting were mentally incapable of executing their defensive roles with the speed and coordination the plan required. The delay and confusion created by shell shock provided Marines with windows of opportunity to establish footholds that doctrine said should have been impossible. The post-battle damage assessment conducted by Marine engineer officers provided quantifiable evidence of the bombardment's effectiveness against concrete fortifications. Of the nearly 500 pillboxes and bunkers on Betio, approximately 200 had been destroyed outright, meaning the structures were collapsed or sufficiently damaged that they could not function as fighting positions. Another 150 had suffered moderate to heavy damage that reduced their effectiveness. Walls partially breached, roofs collapsed, firing ports blocked by debris, interiors damaged by blast effect. Approximately 150 positions had survived the bombardment largely intact, either because they were located in dead ground where naval gunfire could not effectively engage them, or because their construction was sufficiently robust to withstand the shells that hit them. The engineering analysis concluded that 16-inch armor-piercing shells could penetrate up to 4 feet of standard reinforced concrete before detonating, and that high-explosive shells could create craters 2 to 3 feet deep in concrete with each hit. The coconut log and sand protective covering, while providing some protection against blast effects, could be progressively stripped away by sustained fire, eventually exposing the concrete beneath. The analysis noted that bunkers which had received 6 or more direct hits from major caliber shells, meaning 8-inch or larger, showed a failure rate above 80%. The lesson was clear. Concrete fortifications could be destroyed by naval gunfire, but it required heavy shells, precision engagement, and sustained bombardment with multiple hits per structure. This represented a major validation of American fire support doctrine, and a corresponding invalidation of Japanese defensive assumptions. The numbers told a story of engineering confidence meeting physics and losing. The comparison of American shell expenditure at Tarawa with Japanese expectations documented through captured plans revealed the scale of miscalculation inherent in Shibasaki's confident prediction. Captured Japanese defensive plans from Betio, recovered from the command bunker after its capture, included estimates of expected American pre-invasion bombardment based on previous operations. Japanese planners had estimated approximately 400 to 600 tons of naval shells would be expended over a period of 2 to 4 hours, based on observation of American operations at Guadalcanal and in the Solomons. The actual American expenditure at Tarawa exceeded 4,000 tons delivered over more than 3 hours of intensive bombardment, followed by close support fire that continued for 3 days. The Japanese estimate had been off by a factor of 7 to 10. This miscalculation stemmed from several sources. First, Japanese intelligence had failed to track the expansion of American battleship strength as older vessels were repaired and modernized following Pearl Harbor. By November 1943, the Pacific Fleet had more battleships available for fire support than Japanese planners realized. Second, Japanese observers had noted American bombardments at earlier landings, but had not appreciated that those operations were conducted under tactical constraints, with limited time for fire preparation and fewer ships allocated. The Tarawa operation represented the first time the Fifth Fleet had concentrated maximum firepower for a deliberate assault on a heavily fortified objective. Third, Japanese planners had underestimated American willingness to expend ammunition at rates that would be logistically difficult to sustain. The 1,200 to 1,300 rounds of 16-inch shells fired at Tarawa represented a significant percentage of available ammunition stocks, an expenditure Japanese officers considered wasteful. American planners considered it necessary investment to save Marine lives and ensure success. The divergence in military-industrial philosophy was stark. Japan rationed firepower to conserve limited resources. America expended firepower lavishly because industrial capacity could replace it. Shibasaki's confidence had been based on assumptions about American capability and doctrine that were at least 1 year out of date. He was defending against the American military of 1942. He faced the American military of late 1943, transformed by mobilization and hard-won tactical lessons. The intelligence failure that led to Japanese underestimation of American naval firepower extended beyond simple miscounting of ships or shells. It reflected a deeper failure to understand the rapid evolution of American operational doctrine driven by hard experience. Between the Guadalcanal landings in August 1942 and the Tarawa assault in November 1943, the U.S. Navy and Marine Corps had conducted numerous amphibious operations that progressively refined fire support techniques. Early landings had suffered from poor coordination between ships, aircraft, and ground forces. Bombardment had been hasty in general rather than systematic. Spotting and fire control were primitive. By Tarawa, the Fifth Fleet had developed elaborate fire support plans with specific target assignments, systematic spotting procedures, integration of aerial observation, and flexible fire control that could shift from preparation fires to close support as the battle evolved. The creation of joint assault signal companies, specially trained units that accompanied assault waves and directed naval gunfire onto specific targets using radio communication, represented a tactical innovation the Japanese had not anticipated. These forward observers on the ground could call precision fire from battleships and cruisers onto bunkers holding up the advance, bringing the full weight of naval artillery to bear on individual positions within minutes. The speed and accuracy of this on-call fire support represented a revolutionary capability. Japanese defenders found themselves targeted by 16-inch shells based on real-time intelligence from observers often less than 100 yards away. The psychological effect was devastating. Defenders could not hold any position that revealed itself without immediately attracting overwhelming fire. This collapsed the Japanese defensive concept of strongpoints holding out even after being bypassed, because isolated positions could be systematically obliterated by naval gunfire at any time. The Americans had solved the fundamental problem of amphibious assault: how to bring heavy, sustained firepower to bear in support of infantry advancing inland from beaches. The answer was to keep the ships close and maintain continuous communication with forces ashore. The naval artillery doctrine validated at Tarawa drew directly from British experience in the First World War, updated with American innovations in fire control and logistics. The concept of weight of fire, overwhelming fortifications, had been proven in France during 1915 to 1918, where sustained artillery bombardment could destroy even the deepest bunkers given enough time and shells. American fire support planners had studied these lessons and adapted them for naval application. The key insight was that fortifications had a cumulative damage threshold. Sustained hits progressively degraded structural integrity until catastrophic failure occurred. A bunker that could survive one 16-inch hit might survive 5, but would likely fail on the 10th. The American fire plan called for systematic re-engagement of targets until destruction was confirmed. This doctrine required logistical capacity that exceeded anything the Japanese could match. The ammunition ships supporting the Tarawa bombardment carried thousands of tons of shells specifically brought forward to support this operation. When battleship magazines ran low during the bombardment, they could be replenished from ammunition ships standing by. The logistics of moving shells from factory in America to battleship magazine off Betio represented an industrial and organizational achievement that Japanese planners had not believed possible. American industrial capacity could produce shells faster than ships could fire them. American logistics could transport them across 5,000 miles of ocean and maintain ships in action continuously. This was total war leveraging industrial society's full capacity, something that Japan's more limited industrial base could not replicate. Shibasaki's confidence had rested not just on concrete thickness, but on an assumption that American industrial power could not be effectively projected across the Pacific. He was wrong about the concrete, and he was catastrophically wrong about American logistics. The human cost of the Tarawa battle, despite the effectiveness of the naval bombardment, demonstrated the brutal reality that even partially destroyed defenses could inflict terrible casualties. The 2nd Marine Division suffered 3,166 total casualties, including 1,000 killed in action and 30 Navy corpsmen killed. These losses occurred in just 76 hours of fighting on an island 2 miles long and 800 yards wide at its widest point. The casualty rate shocked the American public and led to intense questioning of the tactics employed. Critics pointed to the low-tide disaster as proof that amphibious doctrine was fundamentally flawed. But Marine commanders and naval officers drew different lessons. The casualties, while horrific, had occurred despite defenders being better fortified than any previous objective. Without the intensive naval bombardment, the casualties would likely have been far worse, potentially making the landing impossible. The Marines who survived the battle overwhelmingly credited naval gunfire with enabling their success. Private Russell Davis of the 2nd Battalion, 8th Marines, stated in a letter home preserved in Marine Corps archives, "Those big guns from the battleships saved our lives. I saw bunkers that had been blown to pieces. If those positions had been intact when we came ashore, we would have all been killed in the water. As it was, the Japs still had enough guns working to make it hell. I cannot imagine what it would have been like if the Navy had not worked them over so hard." This sentiment, repeated in after-action interviews with hundreds of Marines, validated the doctrine, even as it highlighted room for improvement. The lesson was not that naval bombardment had failed. The lesson was that even more intensive bombardment was needed, and that new weapons like specialized bunker-busting bombs and rockets should supplement naval guns. The Tarawa bombardment represented the baseline, not the ceiling, of American firepower application. The immediate tactical consequence of the Tarawa bombardment's partial success was a complete reassessment of American fire support doctrine for future amphibious operations. Within weeks of the battle's conclusion, Admiral Spruance and Marine Lieutenant General Holland Smith convened conferences to analyze lessons learned and develop improved procedures. The primary conclusion was unambiguous. Naval gunfire could destroy heavily fortified positions, but 3 hours of bombardment was insufficient for an objective as heavily defended as Betio. Future operations would require longer preparation fires, more systematic target identification, larger ammunition expenditure per target, and better integration of different weapon systems. The Marshall Islands operations scheduled for early 1944 would implement these lessons. At Kwajalein Atoll in January 1944, American forces would spend 7 days conducting air and naval bombardment before the assault, compared to 3 hours at Tarawa. The results validated the revised doctrine. Casualties were dramatically lower, and the assault succeeded faster despite facing similar fortifications. At Eniwetok in February 1944, 5 days of preparation fires preceded the landing. By the time American forces reached the Marianas in June 1944, pre-invasion bombardment had evolved into elaborate week-long campaigns, combining naval gunfire, strategic bombing by B-24 Liberators, carrier strikes, and even underwater demolition teams destroying beach obstacles before the assault began. The firepower applied to each square mile of defended territory increased exponentially with each operation. Tarawa had established the baseline. Concrete fortifications could be destroyed, but it required sustained, overwhelming force. Each subsequent operation moved further along the curve of firepower application. The effect on Japanese defensive doctrine was equally profound and represented a strategic defeat extending far beyond the loss of one atoll. Imperial General Headquarters received detailed reports from the few survivors of Tarawa and from intelligence officers who interviewed prisoners taken at subsequent operations. The reports documented that concrete fortifications, even when massively constructed, could not survive sustained American naval bombardment. This understanding forced a fundamental reassessment of defensive strategy. If concrete bunkers were not proof against 16-inch shells, what fortification style could work? The answer Japanese planners developed was to abandon fixed fortifications exposed on the surface and instead construct deep underground tunnel systems where defenders would be immune to naval gunfire. This doctrine, called defense in depth underground, was first implemented at Peleliu in September 1944, and then progressively refined at Iwo Jima and Okinawa. At Iwo Jima, Japanese defenders constructed 11 miles of tunnels connecting bunkers, command posts, and fighting positions, nearly all located underground. Naval bombardment could destroy surface structures, but could not reach the tunnels. The result was that Iwo Jima, despite receiving the longest and most intensive naval bombardment of the Pacific War, proved even more costly to capture than Tarawa on a per-day basis. The Japanese had learned and adapted. But this adaptation itself demonstrated the strategic impact of Tarawa. Japanese forces were driven underground, surrendering mobility and tactical flexibility. Defenders in tunnels could not observe the battlefield effectively, could not shift forces to meet threats, could not coordinate defenses across the whole position. They could only hide and emerge to fight at close range. American flamethrowers, satchel charges, and ultimately napalm proved effective against tunnel systems. The evolution from concrete fortifications to tunnels represented not Japanese strategic improvement, but rather the exhaustion of defensive options in the face of overwhelming American firepower. The industrial and logistical dimension of naval firepower superiority demonstrated at Tarawa extended beyond the battle itself to encompass the entire American war effort. The ability to expend 4,000 tons of naval shells in a single operation required not just ships and guns, but a complete industrial supply chain stretching back to factories in Pennsylvania, Illinois, and California. Each 16-inch armor-piercing shell required approximately 2,700 pounds of forged steel for the body, produced in mills like Bethlehem Steel or U.S. steel plants. The explosive filler required TNT manufactured in chemical plants. The propellant charges required cordite produced in specialized facilities. Each component had to be manufactured to precise specifications, transported across the country to assembly facilities, loaded onto ammunition ships, conveyed across thousands of miles of ocean, and delivered to battleships operating off remote Pacific atolls. This supply chain represented the mobilized industrial capacity of an entire continent, dedicated to projecting power across the world's largest ocean. Japan, with its far smaller industrial base already stretched to support operations across China, Southeast Asia, and the Pacific, could not replicate this logistical feat. Japanese battleships and cruisers carried similar caliber guns, but the ammunition available for bombardment operations was severely limited by production capacity and transport constraints. Japanese naval doctrine emphasized conservation of ammunition for fleet engagement against enemy warships, not expenditure on shore bombardment. This reflected not doctrinal preference but industrial limitation. The shells did not exist in sufficient quantity to support Tarawa-style bombardments. Even if they had existed, the merchant shipping capacity to transport them across oceanic distances while also supporting army operations did not exist. The Tarawa bombardment was not merely a tactical application of firepower. It was a demonstration that the American economy could produce and project destruction faster than the Japanese economy could produce defenses. This was industrial warfare at its most fundamental, and Japan was losing that war regardless of tactical skill or courage of individual defenders. The personal stories of individual Marines who survived the Tarawa assault because of naval gunfire effectiveness provided human context to the strategic and tactical analysis. Corporal William Hawkins of Scout Sniper Platoon, who would later receive the Medal of Honor for actions during the battle, described in his after-action report the moment his unit approached the beach. "We could see the island through the smoke and dust. It looked like hell on earth. Everything was on fire or blown up. I thought maybe this would be easy because the Navy had wrecked everything. Then the Japs started shooting, and I realized there were still plenty of them left. But as we fought inland, we found dozens of bunkers that had been blown open by the big shells. We could see where shells had gone right through concrete walls 3-4 feet thick. Some bunkers had collapsed completely. If all of those positions had been intact and fighting, we never would have made it off the beach. The Navy gave us a chance. We still had to fight for every yard, but it was possible because so many Jap positions had been destroyed before we landed." Hawkins died on the second day of the battle, but his observations captured the perspective of infantrymen on the receiving end of American firepower doctrine. It was not perfect, but it was effective enough to make the impossible merely extraordinarily difficult. Private First Class Robert Sherrod, a combat correspondent who landed with the assault waves and later wrote the definitive account, Tarawa, the Story of a Battle, observed a destroyed Japanese bunker that had received a direct hit from a 16-inch shell. The shell had penetrated the roof, which was concrete reinforced with steel rails and covered with several feet of sand and coconut logs. It had detonated inside. The walls were blown outward. Nothing inside could have survived. The Japanese had believed these bunkers were impregnable. They were wrong. These individual observations, collected from hundreds of Marines and compiled in after-action reports, built a comprehensive picture of firepower effectiveness, measured not in tons of shells, but in lives saved and objectives achieved. The technological innovations emerging from Tarawa bombardment analysis accelerated development of specialized naval gunfire ammunition and techniques. Engineers at the Bureau of Ordnance began developing improved bunker-busting shells with reinforced nose cones and enhanced penetration characteristics. The Mark 13 and Mark 14, heavy concrete piercing bombs, originally designed for aerial delivery against hardened targets, were adapted for naval rifle use by designing shells with similar penetration characteristics. Fire control radar systems were refined to improve accuracy at longer ranges and in poor visibility. The development of proximity-fused shells, already underway for anti-aircraft use, was expanded to include ground bombardment applications, where airbursts could suppress defenders in open positions or trenches. Perhaps most significantly, the coordination of naval gunfire with close air support led to the development of the Joint Operations Center concept, where naval gunfire controllers and air support coordinators worked side by side with shared communications to rapidly shift fires between ships and aircraft as the tactical situation developed. By 1945, American fire support had evolved into a seamless system where Marine riflemen could call down 16-inch shells or 500-pound bombs on targets within minutes, using standardized radio procedures. This represented a transformation of amphibious warfare doctrine that began with the hard lessons of Tarawa. The bombardment had been effective, but improvable. American military culture embraced continuous improvement, applying engineering and industrial solutions to tactical problems. Each operation learned from previous ones, building institutional knowledge. Japanese military culture, more rigid and hierarchical, adapted more slowly and with less effectiveness. The result was a widening gap in combat effectiveness over time. The strategic impact of Tarawa's validation of American firepower doctrine extended beyond the Pacific War into post-war military theory. The battle demonstrated that fortifications, no matter how strong, could be overcome by sufficient application of firepower combined with determined assault. This lesson influenced American military planning throughout the Cold War. The doctrine of overwhelming firepower supporting precision assault became foundational to American military operations. In Korea, naval gunfire from battleships and cruisers provided fire support for ground operations, with techniques refined at Tarawa applied to new tactical situations. During the First Gulf War in 1991, the concept of intensive bombardment preceding ground assault was applied at the operational level, with weeks of air campaign destroying Iraqi fortifications before the ground offensive began. The 100-hour ground war's success owed much to firepower doctrine validated 48 years earlier at Tarawa. The modern American military's emphasis on precision strike, whether from aircraft, ships, or missiles, traces intellectual lineage to the realization at Tarawa that superior firepower, properly applied, could substitute for manpower and reduce casualties. The human cost of frontal assault could be reduced through application of material superiority. This was fundamentally American military philosophy. Leverage industrial and technological superiority to minimize loss of life while achieving objectives. Tarawa was the battle where this philosophy was tested against the strongest fortifications an adversary could construct and found to be valid, if imperfect. Admiral Shibasaki's death during the battle, while never precisely documented as to timing or circumstance, represented the final collapse of Japanese confidence in the impregnable fortress doctrine. Reports from survivors suggested he died sometime on the second day, November 21, 1943, when Marines fighting inland reached the command bunker complex and engaged it with flamethrowers and satchel charges. Other accounts suggested he may have been killed by naval gunfire that struck the command post. The uncertainty itself reflected the chaos of the battle and the destruction of Japanese command and control. What is certain is that Shibasaki witnessed the failure of his defenses before he died. Radio communications captured by American intelligence teams included fragments of transmissions from the command bunker describing the effectiveness of American firepower and the collapse of defensive positions. One transmission, intercepted on the evening of November 20th, reportedly stated, "Enemy firepower overwhelming, many positions destroyed, situation critical." Whether Shibasaki personally sent this message or whether it came from staff officers is unclear, but it documented the reality that the admiral who had confidently proclaimed Tarawa could not be taken in 100 years by 1,000,000 men was watching it fall in a matter of hours to 18,000 Marines supported by firepower he had catastrophically underestimated. The irony was complete. The bunker built to protect command and control became a tomb. The concrete meant to provide confidence provided only delay. Shibasaki had gambled on engineering superiority and lost to industrial capacity. His confident prediction became an epitaph for the obsolescence of fixed fortifications in the age of industrial firepower. The testimony of Lieutenant Commander Tadao Nakamura, one of the senior surviving Japanese officers captured on Tarawa, provided the most detailed account of Japanese recognition that their defensive assumptions had been invalidated. Nakamura, who had been stationed at a coastal defense battery and survived when his position was bypassed by the initial Marine assault, surrendered on the third day after running out of ammunition and water. In interrogation, documented in 5th Fleet Intelligence Report G2 Summary, dated December 1943, Nakamura stated, "We were confident because Admiral Shibasaki told us the defenses were the strongest in the Pacific. The concrete was very thick, we had strong guns and many troops. We thought the Americans would fail at the beaches. When the bombardment began, it was much worse than we expected. The shelling continued for hours. We had never experienced anything like it. Many positions were destroyed before the landing even began. When Marines came ashore, our defensive plan was already broken. Too many positions were silent. The ones still fighting could not coordinate because communications were destroyed. I realized during the first day that we would lose. The American firepower was simply too great. Our concrete could not protect us. Our guns could not stop them. We fought on because of duty, but I knew the outcome." This testimony, corroborated by other prisoners, documented the psychological impact of realizing during combat that fundamental assumptions were wrong. The defenders had believed in their fortifications. The fortifications failed. The defenders fought on out of discipline and courage, but with the knowledge that defeat was inevitable. This was strategic defeat manifested at the tactical level. The broader intelligence picture revealed through captured documents and prisoner testimony exposed the extent to which Japanese military leadership had misunderstood American industrial and military capability throughout the war. Tarawa was not an isolated miscalculation. It was part of a pattern of underestimation that characterized Japanese strategic planning from Pearl Harbor forward. Japanese planners in 1941 had calculated that America lacked the will to fight a prolonged war and would seek negotiated peace after initial defeats. By 1943, that calculation was obviously wrong, but institutional thinking had not adapted. Japanese officers still spoke of American softness and lack of fighting spirit, even as evidence accumulated of American technological superiority, industrial capacity, and tactical competence. The Tarawa bombardment represented a moment when evidence could no longer be denied. The shells were real. The destruction was visible. The concrete had failed. Prisoners reported that some officers expressed shock that America would expend so much ammunition on a single small island, viewing it as wasteful. They failed to understand that American industrial capacity made such expenditure not wasteful, but routine. The shells would be replaced within weeks. More ammunition was being manufactured even as the bombardment occurred. This was warfare by industrial power, and Japan was hopelessly outmatched in that dimension. Yet Japanese planning continued to assume that somehow, through fighting spirit and tactical excellence, they could compensate for material inferiority. Tarawa demonstrated the limits of that assumption. No amount of courage could enable men in bunkers to survive 16-inch shells. No level of tactical skill could allow defenders to fight effectively when their positions were being systematically obliterated by firepower they could not counter. The revelation of American superiority was complete. The post-war analysis by Japanese military historians and surviving officers acknowledged Tarawa as a turning point in Pacific War defensive doctrine. Senshi Sosho, the official Japanese war history series published by the Japan Defense Agency beginning in the 1960s, devoted significant attention to the Battle of Tarawa and its implications. The analysis concluded that Japanese defensive doctrine prior to Tarawa had been predicated on assumptions about American firepower that were disproven during the battle. The shift to underground tunnel defenses at subsequent battles represented Japanese adaptation, but the analysis acknowledged this was adaptation born of desperation rather than strategic breakthrough. The tunnels protected defenders from bombardment, but sacrificed tactical flexibility. Iwo Jima and Okinawa demonstrated that underground defenses could prolong battles and increase American casualties, but could not change outcomes. The industrial and firepower superiority demonstrated at Tarawa persisted through every subsequent operation. Japanese historians noted that Shibasaki's confident prediction, while proven disastrously wrong, reflected broader Japanese military culture of projecting confidence regardless of objective circumstances. The culture valued determination and dismissal of enemy capability. This served morale purposes but led to catastrophic miscalculations at the strategic level. The inability to accurately assess enemy capabilities and adjust planning accordingly was identified as a systemic failure. Tarawa was merely the most dramatic example. The bombardment had physically destroyed Japanese defenses. The broader revelation destroyed Japanese confidence in their defensive strategy. Both losses were unrecoverable. The human dimension of the Tarawa bombardment, often lost in discussions of tonnage and concrete thickness, emerged through the accounts of individual Japanese defenders struggling to survive the onslaught. Petty Officer Tadao Onuki, whose testimony was quoted earlier, provided additional details about the psychological experience of being bombarded. Time lost meaning, he told interrogators. We could not tell if it had been 10 minutes or 2 hours. The sound merged into one continuous roar. Between explosions, we heard nothing because our ears were damaged. Some men began crying. Others prayed. Some just sat staring at nothing. When a shell hit close, the bunker shook and we thought it would collapse. We expected to die. When the shelling finally stopped, it took minutes before we understood it had stopped because our ears were still ringing. When we went outside, the world looked strange. The colors were wrong. Everything was gray with dust. The trees were gone. I saw a man from another position wandering around. He was just walking with no purpose. When I called to him, he did not respond. I think his mind was broken. This testimony, while representing an enemy perspective, humanized the experience of modern combat's overwhelming firepower. The men inside the bunkers were not abstractions or statistics. They were individuals experiencing terror and destruction on a scale their training had not prepared them for. The revelation was not just intellectual, but visceral. The defenses they trusted were inadequate. The weapons they faced were overwhelming, and survival depended more on chance than preparation. This psychological dimension of firepower superiority received less analysis than the physical effects, but was equally important. Defenders who survived the bombardment physically were often unable to fight effectively psychologically. The will to resist had been broken by hours of sustained bombardment. This was a weapon effect that exceeded simple destruction of material. The final assessment of the Tarawa bombardment's effectiveness came from Admiral Raymond Spruance himself, commander of the Fifth Fleet, in his after-action report dated December 15, 1943. The document, filed with SINCPAC headquarters and later published in part in Naval Histories, provided a measured evaluation that acknowledged both success and limitation. Spruance wrote, "The pre-landing bombardment of Betio Island was the most intensive naval gunfire preparation conducted to date in this theater. Approximately 4,000 tons of shells were expended against an area of 2 square miles. The bombardment achieved significant destruction of concrete fortifications through sustained application of heavy-caliber fire. Approximately 40% of identified defensive positions were destroyed or heavily damaged prior to the landing. This level of destruction enabled the assault to succeed, but at significant cost due to the remaining 60% of positions that retained capability. Future operations require longer preparation time, more systematic targeting, and larger ammunition allocation per identified position. The lessons of Tarawa validate the doctrine that heavily fortified positions can be overcome through naval gunfire, but the resources required exceed initial estimates. The bombardment was effective but insufficient. Sufficiency requires additional ships, more ammunition, longer preparation time, and improved coordination between fire support and assault elements. These requirements can be met in future operations with proper planning. Spruance's careful analysis captured the essential truth. The bombardment worked, but needed improvement. This was the American military at its best, learning from experience and applying lessons systematically. The next operation would be better. Each operation after that would be better still. Continuous improvement was institutional doctrine. The legacy of the Tarawa naval bombardment extended far beyond the immediate tactical lessons into the realm of strategic deterrence and international perceptions of American military capability. For Allied forces in other theaters, the battle demonstrated that the United States could project overwhelming firepower across oceanic distances in support of amphibious operations. This had implications for planning the European invasion scheduled for 1944. British planners studying Tarawa noted the scale of fire support applied and adjusted their own fire plans for Normandy accordingly. The D-Day landings in June 1944 would benefit from lessons learned at Tarawa about coordination of naval gunfire, aircraft, and ground assault. For neutral nations observing the war, particularly the Soviet Union, the Tarawa bombardment provided evidence of American industrial and military capacity that influenced post-war calculations. Soviet intelligence services obtained detailed reports on the Tarawa operation through various channels and conducted analysis of American firepower capabilities. The conclusion, reflected in Soviet military journals published after the war, was that American industrial capacity could generate firepower on a scale that exceeded even Soviet production. This informed Stalin's negotiating positions at Tehran and Yalta. If America could expend 4,000 tons of shells on a single small island that held no strategic value beyond being a stepping stone, what resources could it deploy in operations that truly mattered? The demonstration of casual abundance in firepower expenditure conveyed strategic messages beyond the immediate tactical context. For the Japanese government and military leadership in Tokyo, the reports from Tarawa triggered strategic debates about whether the war could be continued at all. The loss of the Gilbert Islands was not strategically crippling in itself. The revelation of American firepower superiority and its implications was far more damaging. If America could obliterate heavily fortified positions through sustained bombardment, and if American industrial capacity could sustain such bombardments operation after operation, then the strategy of defending island strongpoints to impose unacceptable casualties was fundamentally flawed. The Americans would simply bombard each island into submission, accept the logistical cost because they could afford it, and advance steadily toward Japan. No defensive position would hold. The strategic debate in Tokyo split between those who advocated negotiated peace, while Japan still held some bargaining chips, and those who insisted on continued resistance, hoping that American will would break under the accumulating casualties. The debate was resolved in favor of continued resistance, but Tarawa had introduced doubt into even the most optimistic assessments. Captain Mitsuo Fuchida, the Pearl Harbor attack commander who later served in intelligence analysis roles, wrote in post-war memoirs that Tarawa reports convinced him personally that Japan would lose the war. When I read the reports of the bombardment and the destruction of concrete fortifications, I understood that we could not defend against such firepower. Each island would fall. Eventually, the home islands would be attacked. We had no answer to American industrial power. Fuchida's assessment, while personal, reflected a growing realization among informed Japanese officers that the strategic situation was hopeless. Tarawa made that truth undeniable. The cultural and psychological impact on American military confidence was equally significant. Prior to Tarawa, there existed uncertainty about whether the island-hopping strategy could succeed against heavily fortified objectives. The casualties sustained at Tarawa initially seemed to validate concerns that amphibious assault was too costly, but as analysis proceeded and the effectiveness of naval gunfire became clear, the lessons shifted confidence in a positive direction. The military and industrial system had functioned, the ships had delivered firepower, the Marines had executed the assault, the island had fallen in 76 hours. Yes, casualties were heavy, but they were sustainable given the scale of American mobilization. More importantly, clear paths to improvement existed. Future operations would be better planned with more firepower. The trajectory was clear. American forces would get better at amphibious warfare with each operation. This confidence permeated planning for subsequent operations. Commanders approached the Marshalls, Marianas, Palau, Philippines, Iwo Jima, and Okinawa with confidence that while each would be difficult, none would be impossible. The firepower existed to destroy enemy defenses. The logistics existed to sustain operations. The training existed to execute complex assaults. Tarawa had been a crucible that tested the system and found it fundamentally sound. The confidence generated translated into operational tempo. Each major offensive in the Pacific came faster than Japanese defenders anticipated because American planners were confident in their capability to succeed. The technological legacy of Tarawa influenced American military development for decades. The demonstration that heavy naval gunfire could destroy fortified positions encouraged continued development of large-caliber naval guns, even as aviation advocates argued that aircraft had made battleships obsolete. The Iowa-class battleships, with their 9 16-inch guns, were recognized as valuable fire support assets for amphibious operations. These ships served in Korea, Vietnam, and even in the 1991 Gulf War, providing fire support with guns directly descended from those used at Tarawa. The proximity-fused shells developed after Tarawa remained standard ammunition through the Cold War. The fire support coordination procedures developed for naval gunfire evolved into the joint fires doctrine used by modern American forces, where artillery, naval gunfire, close air support, and attack helicopters are coordinated through centralized fire control centers. The institutional knowledge that overwhelming firepower properly applied could achieve objectives remained fundamental to American military thought. The defense budget debates of subsequent decades often revolved around maintaining sufficient firepower to handle any contingency, an echo of lessons from Tarawa that adequate firepower required significant investment but paid dividends in lives saved and objectives achieved. The bombardment's legacy was technological, doctrinal, and cultural, shaping American military identity as a firepower-intensive force that substituted material for manpower where possible. The memorial dimensions of Tarawa, both physical and historical, preserved the lessons of the bombardment for future generations. The Tarawa Atoll, now part of the Republic of Kiribati, contains numerous memorials to the battle. Remnants of Japanese fortifications remain visible, many showing damage from heavy naval shells. The craters and broken concrete serve as physical testimony to the firepower applied. American military historians regularly visit Betio to study the battlefield and teach lessons about amphibious warfare to new generations of officers. The Marine Corps uses Tarawa as a case study in professional military education, analyzing both the bombardment's effectiveness and the tactical execution of the assault. The famous phrase attributed to Holland Smith, "Tarawa was a mistake," is contextualized in modern teaching not as condemnation of the operation, but as recognition that future operations required better preparation, including longer bombardment. The historical memory preserves both the courage of Marines who fought across the island and the effectiveness of naval forces who supported them with firepower. The balance between criticism and recognition reflects mature historical understanding. Tarawa was costly but necessary, improvable but fundamentally sound in concept. a hard lesson that taught essential truths about amphibious warfare. The memorials honor sacrifice while teaching lessons that ensured future sacrifices achieved better results. The final word on the Tarawa bombardment perhaps belongs to the Marines who assaulted the island and lived to reflect on their experience. Staff Sergeant William Bourdillon, who received the Medal of Honor posthumously for actions on Betio, wrote a letter to his mother before the battle that was delivered after his death. In it, he mentioned preparation for a major operation and expressed confidence in the Navy's support. "We have been told that the Navy will work over the objective before we go in. The battleship boys have promised to knock down everything standing. I believe them. Those 16-inch guns are something special. If they do their job, we will have a chance to do ours." Bourdillon died on the first day destroying Japanese pillboxes with satchel charges, but his words captured the essential relationship between firepower and assault. The bombardment created opportunity. The infantry exploited it. Neither could succeed alone. Together, they were irresistible. This partnership between fire support and ground assault, validated at Tarawa and refined through subsequent operations, defined American amphibious doctrine for the remainder of the war and beyond. The naval artillery barrages that shattered Japanese defenses at Tarawa demonstrated that Admiral Shibasaki's confident prediction of impregnability was based on assumptions about American capability that were tragically wrong. The 1,000,000 men were not needed. The 100 years were not required. What was required was industrial capacity to produce shells, logistics to deliver them, ships to fire them, and the doctrine to apply them systematically. America possessed all of these. Japan possessed none in sufficient quantity. The revelation was complete, the lesson indelible, and the outcome inevitable. The technical analysis of specific fortification failures at Tarawa provided granular understanding of how naval shells interacted with reinforced concrete under combat conditions. Marine engineers who examined destroyed pillboxes after the battle documented the mechanics of failure with scientific precision. A typical bunker that received a direct hit from a 16-inch armor-piercing shell showed a penetration hole approximately 18 to 24 inches in diameter through the entry wall. The shell, having passed through 4 to 5 feet of concrete, detonated inside the structure, creating blast overpressure that exceeded 100 pounds per square inch within the confined space. This pressure wave was sufficient to cause catastrophic injury to any personnel inside through blast lung trauma, even if shrapnel did not strike them directly. The walls bulged outward from internal pressure, and in many cases, the roof structure separated from the walls and collapsed. Bunkers that received multiple hits from high-explosive shells showed progressive degradation. The first hit created a crater 2 to 3 feet deep in the concrete surface and spalled fragments from the interior wall. The second hit deepened the crater and created structural cracks radiating from the impact point. The third hit often penetrated through the weakened section. The engineers noted that concrete quality varied significantly across different fortifications. Bunkers constructed early in the fortification program with high-grade cement and proper steel reinforcement showed greater resistance to damage. Later constructions, built as cement supplies dwindled, used lower-quality concrete with beach sand and coral aggregate that lacked the compressive strength of properly formulated concrete. These later bunkers failed more readily under bombardment. One structure examined by Captain Paul Stevens, a Marine engineer officer, showed a direct hit from what was assessed as an 8-inch cruiser shell that had penetrated through the roof, traveled through 2 interior walls, and exited through the rear wall before detonating outside. Stevens noted in his report, "The shell passed completely through the structure like a bullet through wood. The bunker was rendered unusable, not through collapse but through the entry and exit holes, creating fatal vulnerabilities. Defenders inside would have been killed by shell passage even without detonation." This analysis demonstrated that even bunkers that appeared structurally intact were often combat ineffective due to damage that compromised their protective function. The comparative analysis of American naval gunfire effectiveness at Tarawa versus Japanese defensive preparations elsewhere revealed the extent to which Betio represented the high-water mark of Japanese fortification efforts. Intelligence officers comparing Tarawa with defenses encountered later at Kwajalein, Eniwetok, and Saipan found that none matched Betio's concentration of concrete fortifications. Shibasaki had been given 8 months and priority access to resources. Later island commanders received less time and fewer materials, as American submarine warfare strangled Japanese logistics, and as cement production in the home islands fell due to bombing and resource shortages. The defenses at Kwajalein, assaulted just 2 months after Tarawa, were noticeably lighter despite being geographically closer to Japan. Bunkers had thinner walls, fewer positions were fully concrete, and more defensive positions relied on coconut log construction supplemented by limited concrete. This progression reflected Japan's declining capacity to fortify positions as the war progressed. Ironically, Shibasaki's fortress at Tarawa represented the best defense Japan could construct, and the American bombardment had demonstrated it was inadequate. Every subsequent defense would be weaker, not stronger, because Japan lacked the resources to build to Tarawa standards again. The industrial trajectory favored America increasingly over time. Each month of war meant more American ships, more shells produced, better doctrine refined, while Japanese capacity steadily declined. The gap revealed at Tarawa in November 1943 would widen with each passing month, until by 1945 it became an unbridgeable chasm. The psychological operations dimension of American firepower superiority, while not deliberately planned as such at Tarawa, emerged as an unintended but powerful weapon in subsequent operations. Japanese defenders who survived Tarawa and were transported to POW camps spoke to other prisoners about the bombardment. These accounts spread through the POW population and through various channels, including returned prisoners in exchanges and intelligence gathered from captured documents, filtered back to Japanese forces preparing defenses on other islands. The tales of bunkers destroyed, positions obliterated, and men killed or driven mad by sustained bombardment created anticipatory fear among defenders who knew they would face similar bombardments. Intelligence intercepts of Japanese radio traffic before the Saipan invasion in June 1944 included references to Tarawa bombardment as shorthand for the expected American fire preparation. Defenders knew what was coming. This knowledge undermined morale before battles even began. American psychological warfare officers, recognizing this effect, deliberately emphasized firepower superiority in leaflets and radio broadcasts directed at Japanese forces. Messages highlighted tonnages of shells available, numbers of battleships in the fleet, technical specifications of American artillery. The intent was to create defeatism by convincing defenders that resistance was futile against such overwhelming material superiority. While the direct effectiveness of psychological operations is difficult to measure, post-war interrogations of Japanese prisoners frequently mentioned fear of bombardment as a significant factor in their psychological state. The firepower demonstrated at Tarawa had become a weapon of psychological warfare, eroding enemy will to resist before the first shot of new battles was fired. The diplomatic dimension of American firepower demonstration influenced neutral nations' calculations about the war's likely outcome. Turkey, maintaining precarious neutrality between the Allies and Axis, received detailed intelligence reports on the Tarawa operation through its embassy in Washington and through neutral observers. Turkish military analysts assessed that American industrial capacity to project such firepower across the Pacific indicated likely Allied victory. This assessment influenced Turkey's decision to move closer to the Allied camp in 1944, eventually declaring war on Germany in February 1945 to secure post-war positioning. Similarly, Argentina and Chile, officially neutral but with military establishments that admired German efficiency, reconsidered their positions as evidence of American material superiority accumulated. Intelligence services in these countries obtained documentation of American shell production rates, ship construction timelines, and logistical capacity. The analysis concluded that no nation could match American industrial output in extended warfare. This influenced Latin American policy toward closer cooperation with the United States, despite cultural and political reservations. Spain, still under Franco's dictatorship and sympathetic to Axis ideologies, nevertheless maintained careful neutrality, partly because military advisors understood that American capacity to project power globally made antagonizing Washington strategically suicidal. The Tarawa bombardment, reported in international press and analyzed by military attachés worldwide, served as advertisement of American power that influenced strategic calculations far beyond the Pacific theater. The historical irony of Tarawa's legacy centered on the reality that the battle's tremendous cost in American casualties, initially seen as a failure of doctrine, ultimately validated the doctrine while revealing the need for more, not less, application of its principles. Critics who pointed to the 1,000 dead Marines argued that amphibious assault against fortified positions was fundamentally flawed. Admiral King and General Holland Smith countered that the casualties resulted not from doctrinal failure, but from insufficient application of firepower due to time and resource constraints. The solution was not to abandon island hopping, but to conduct longer bombardments with more shells against each objective. This argument prevailed, and subsequent operations demonstrated its validity. Kwajalein casualties were proportionally lower than Tarawa, despite similar defenses, because the bombardment lasted 7 days instead of 3 hours. Iwo Jima's terrible casualties occurred despite the longest and most intensive bombardment of the war, because Japanese had shifted to underground defenses immune to surface bombardment. The lesson was refined. Naval gunfire could destroy visible fortifications, but could not reach deep tunnels, requiring different weapons like flamethrowers and explosives for underground positions. The doctrine evolved continuously, incorporating lessons from each battle. By war's end, American amphibious assault doctrine represented the most sophisticated integration of firepower and maneuver in military history. Tarawa had been the crucible where this doctrine was tested under the harshest conditions and found fundamentally sound despite tragic cost. The Marines who died on Betio's beaches contributed not just their lives, but the lessons that saved the lives of Marines who landed on subsequent beaches, better prepared and better supported. The economic dimension of the Tarawa bombardment illustrated American strategic thinking that valued material expenditure over human life, a calculation that distinguished American warfare from Japanese philosophy. The 4,000 tons of naval shells expended at Tarawa represented millions of dollars in direct costs, not counting the fuel consumed by ships, the wear on gun barrels requiring replacement, and the logistical costs of transporting ammunition across the Pacific. Japanese officers calculating these costs concluded that America was bankrupting itself through wasteful expenditure. They failed to understand that American economy generated wealth faster than the military could spend it. The gross domestic product of the United States in 1943 exceeded Japan's by a factor of approximately 10 to 1. American industrial production that year included 29,000 aircraft, thousands of tanks, hundreds of ships, and millions of tons of munitions. The shells expended at Tarawa represented a tiny fraction of monthly production. The economic model was sustainable indefinitely because American industry operated at only partial capacity and could expand further if needed. Japan, by contrast, operated at maximum industrial capacity and still could not match American output. Japanese soldiers were told to conserve ammunition because replacement was uncertain. American soldiers were told to use ammunition liberally because resupply was guaranteed. This fundamental difference in material philosophy reflected the underlying economic realities that determined the war's outcome, regardless of tactical skill or individual courage. The Tarawa bombardment was economically trivial to America and economically impossible for Japan to replicate. This asymmetry was the true revelation. Not that American firepower could destroy fortifications, but that American economy could sustain any level of material expenditure necessary to achieve objectives. Industrial capacity was strategic destiny. The enduring professional military education value of Tarawa ensured that lessons from the bombardment continued to influence American military thinking decades after the battle. The Marine Corps' Amphibious Warfare School at Quantico, Virginia, uses Tarawa as a primary case study in courses on amphibious operations, fire support coordination, and combined arms integration. The specific lessons emphasized include the necessity of sustained bombardment against hardened targets, the importance of accurate intelligence on fortification construction, the requirement for combined arms integration between naval gunfire and close air support, and the need for flexible fire control systems that can shift support rapidly as ground situations evolve. Officers studying Tarawa analyze Admiral Kingman's fire plan, critique its execution, and develop alternative approaches as training exercises. The battle provides concrete examples of both success and failure. The success of heavy naval gunfire against concrete fortifications, the failure to adequately account for reef conditions that stranded landing craft. Modern amphibious doctrine, as practiced by American forces in operations from the Falklands consultation role to planning for potential operations in the Western Pacific, traces intellectual lineage directly to Tarawa's lessons. The recognition that amphibious assault requires overwhelming fire superiority to succeed remains foundational. The specific techniques have evolved with precision-guided munitions replacing unguided shells and helicopters, supplementing landing craft, but the principle endures. Use firepower to create opportunity for infantry assault. Tarawa taught this lesson at terrible cost. The military has honored that cost by preserving and applying the lessons in professional military education that prepares each new generation to execute amphibious operations with competence born from institutional memory of hard-won knowledge. The final accounting of Admiral Shibasaki's catastrophic miscalculation reduced to simple mathematics that his confident prediction never accommodated. 1 million men in 100 years equaled 10,000 men per year, or approximately 27 men per day, required to take Tarawa by his calculation. The actual American force that conquered Betio numbered 18,000 Marines, and the island fell in 76 hours. The ratio of actual to predicted time was roughly 1:11,500. Shibasaki's prediction was not merely wrong, but wrong by 4 orders of magnitude. This level of miscalculation reflected not simple error in estimating enemy strength, but fundamental misunderstanding of modern industrial warfare's nature. The admiral had calculated based on the strength of his fortifications, the number of defenders, and tactical considerations of amphibious assault difficulty. He had not calculated for the possibility that an adversary could deliver 4,000 tons of high explosive ordnance with sufficient precision to systematically destroy concrete fortifications across 2 square miles of island. The firepower applied at Tarawa exceeded the total explosive tonnage used in many entire campaigns of previous wars. Shibasaki's frame of reference, based on experience in China, where neither side possessed significant heavy artillery and where warfare often devolved to infantry combat with limited fire support, had not prepared him for industrial-scale firepower application. His confidence had been based on a mental model of warfare that was obsolete before the battle began. The revelation came too late for him personally, dying in his bunker as Marines fought through his shattered defenses. But the revelation echoed through Imperial Japanese military planning for the remainder of the war. Concrete could not stop the Americans. Determination could not overcome material inferiority. The war was lost, though it would continue for another 20 months at terrible cost. The voices of American Marines who fought at Tarawa, preserved in oral histories and memoirs, overwhelmingly credited naval gunfire with making victory possible despite the heavy casualties. Private Carl Matthews of the 2nd Battalion, 2nd Marines, recorded in his memoir From Tarawa to Tokyo, "Before we hit the beach, I thought the Navy was going to blow the whole island into the ocean. The battleships were firing constantly. The noise was incredible even miles away. When we got close to shore and could see the island through the smoke, everything looked destroyed. Then we started taking fire and I realized plenty of Japs had survived. We fought for 3 days through pillboxes and bunkers, but I saw dozens of positions that had been blown apart by naval shells. If all those positions had been intact and fighting, we would have never gotten off the beach. Every Marine who survived Tarawa owes their life to those Navy gunners who blasted the Japanese fortifications before we landed. It wasn't perfect. We still lost 1,000 men, but without that bombardment, we would have lost every man." This sentiment, repeated in countless testimonies, validated the doctrine even as it acknowledged imperfection. The bombardment was necessary but insufficient, effective but improvable. The honest assessment by participants reflected American military culture's strength, willingness to acknowledge both success and failure, to learn from both, and to improve continuously. Japanese military culture, more rigid in its hierarchy and more resistant to admitting error, adapted more slowly. The side that learned faster and adapted better won the war's technical and tactical dimensions before the strategic outcome was determined. The technological evolution from Tarawa's 16-inch naval rifles to modern precision-guided munitions represented continuity of the fundamental principle revealed in November 1943. Firepower properly applied creates conditions for successful assault. A modern destroyer carries fewer than 100 cruise missiles, but each missile can strike within meters of its intended target from hundreds of miles away, delivering explosive effect comparable to large naval shells. The evolution from thousands of unguided shells to dozens of precision weapons reflected advances in targeting and guidance technology, but the underlying doctrine remained constant. Overwhelm defenses through firepower, create opportunities for ground forces, minimize casualties through application of material superiority. The GPS-guided munitions used in Iraq and Afghanistan traced conceptual lineage to fire support coordination developed at Tarawa. The Joint Terminal Attack Controllers who direct precision airstrikes from ground positions descended professionally from the shore fire control parties who directed naval gunfire at Betio. The technology changed radically. The operational concept remained fundamentally similar. American military investment in precision strike capability over subsequent decades reflected institutional commitment to the firepower-centric doctrine validated at Tarawa. The defense budget debates about whether to develop new weapons systems often reference the principle that firepower superiority saves lives by destroying enemy capacity to resist before ground forces engage. Tarawa provided the historical proof point for this argument. The 1,000 Marines who died there were honored by the military's commitment to ensuring future Marines would have even better fire support, even more overwhelming material advantage, even greater probability of survival when ordered to assault defended positions. The counterfactual question, what if Tarawa had been bypassed, illuminated the strategic necessity of the battle despite its terrible cost. Some critics, both contemporary and historical, argued that Tarawa held no intrinsic strategic value and could have been isolated and left to wither while American forces advanced toward more important objectives. Admiral Ernest King, Commander-in-Chief of the U.S. Fleet, addressed this criticism in post-war testimony before Congress. He stated, "Tarawa had to be taken because we needed the airfields and anchorage to support operations against the Marshals. More importantly, we needed to test our amphibious doctrine against heavily fortified positions before attempting larger operations where failure would be catastrophic. Tarawa taught us lessons that saved lives at Saipan, Iwo Jima, and Okinawa. The cost was heavy, but the alternative was learning those lessons at Saipan, where the scale was larger and the consequences of failure would have been far worse. Tarawa was a necessary test under fire of doctrine and capabilities. We passed the test, learned the lessons, and improved our methods. That was worth the cost." King's assessment, while perhaps rationalization after the fact, contained strategic truth. The techniques refined at Tarawa, from extended bombardment to close fire support coordination, directly contributed to reducing casualties at subsequent operations. The organizational learning that occurred because of Tarawa's difficulties made the amphibious campaign across the Pacific more effective. Had those lessons been learned for the first time at Saipan or Iwo Jima, where the defender numbers and fortification scales were larger, the casualties might have been catastrophically higher. Tarawa was terrible but manageable in scale. The lessons learned there were applied at operations that would otherwise have been worse. The strategic value lay not in the island itself, but in the knowledge purchased with marine lives. The personal redemption narrative for naval gunfire crews who participated in the Tarawa bombardment came in the form of subsequent operations where refined techniques saved lives measurably. Gunner's Mate First Class Robert Hayes, who served on USS Colorado at Tarawa and later at Saipan and Tinian, recorded in his diary the evolution of fire support doctrine based on lessons learned. At Tarawa, we fired for 3 hours before the landing. We thought we'd destroyed everything. Then we watched the Marines wade ashore and get shot to pieces by Japs in bunkers we'd missed. It haunted us. We'd failed them. At Saipan 4 months later, we fired for 7 days. We systematically worked over every position until spotters confirmed destruction. When the Marines landed, they still faced resistance, but nothing like Tarawa. We knew we'd done it better. We'd learned. Every shell we fired at Saipan was fired with memory of Tarawa Marines dying because we hadn't fired enough. By the time we got to Tinian, the fire support was so effective that Marines secured the island with fewer casualties than Tarawa, despite it being larger and having more defenders. That was vindication. We'd learned how to do our job properly, and Marines lived because of it. Hayes's testimony captured the personal dimension of institutional learning. Individuals carrying forward lessons learned through tragedy and applying them to do better next time. This was American military culture's great strength, the human foundation beneath doctrine and technology. The system improved because individuals were empowered and expected to learn from experience and share lessons. The feedback loop from combat experience to doctrinal revision to improved practice operated efficiently. Tarawa's lessons were captured, analyzed, distributed, and applied faster than Japanese defenders could adapt to new American techniques. The velocity of learning was itself a strategic advantage. The final words belong to Admiral Raymond Spruance, who bore command responsibility for the Tarawa operation and lived with the weight of the casualties for the rest of his life. In a letter to Admiral Chester Nimitz written in January 1944, Spruance reflected on the lessons of Tarawa. With characteristic understated precision, the operation succeeded in achieving its objectives. Betio was secured, the airfield captured, and the base established for subsequent operations. The cost was higher than anticipated and has generated considerable criticism. Upon reflection, the fundamental concept was sound. Amphibious assault supported by overwhelming naval firepower can succeed against heavily fortified positions. The execution required refinement, longer bombardment duration, more systematic target engagement, better coordination of fires. These refinements are being implemented in planning for forthcoming operations. The men who died at Tarawa accomplished their mission and taught us lessons that will save lives in future operations. That is how we honor their sacrifice, by learning and improving. The Japanese learned at Tarawa that their fortifications cannot stop us. We learned that our firepower doctrine works but requires full application of resources. Both lessons favor us in the long term. The trajectory is clear. We will get better at this with each operation, while enemy capacity to resist diminishes. Tarawa was hard, but necessary. The path forward is clearer because of it. Spruance's assessment, characteristically devoid of emotion but heavy with meaning, captured the essential truth that Tarawa revealed about the Pacific War's trajectory. American industrial and military power, properly applied through doctrine refined by hard experience, would break any defense Japan could construct. The revelation was complete. Admiral Shibasaki's confident prediction lay shattered in the rubble of his bunkers, demolished by a force he had not believed existed. Naval artillery barrages had indeed shattered Japanese island defenses at Tarawa, and in doing so had shattered Japanese confidence that the Pacific could be defended at all. The strategic dominance proclaimed in the battle's title was not aspiration, but documented historical fact, proven through 4,000 tons of high explosive delivered with industrial precision against fortifications built on assumptions that proved fatally wrong.